Hey guys, very good morning. My name is Mithilesh Singh. This is the fifth part of AWS Transit Gateway. In today's session, we will see how can we configure Transit Gateway to control outbound traffic. Okay, so let's see in detail. So this is our design. Under this design, you can see I have a VPC A, B, and remote VPC, which I use to deploy the virtual machine, database, or other AWS resources. In other side of Transit Gateway, I have egress VPC, which I will use to route all internet traffic from VPC A, B, and remote VPC. Let's suppose you do not have Transit Gateway and you want to access the internet from this VPC. So what all you need, first of all, you have to configure a NAT under this and then IGW so that you can route your traffic from this private virtual machine to the internet. Okay, while you send the traffic, you do not have control over the data monitoring, what kinds of traffic your virtual machine is sending or what kinds of site your virtual machine is accessing from the internet. And other complexities, if you have hundreds of VPC and you want to set up this and you want to allow all your virtual machines to access the internet, then you have to do the same setup in all 100 account, which is repeated task and become complex in terms of monitoring and configuration. So let's reduce this complexity and see how can we centralize all outbound traffic by a single VPC using the transit gateway. To set up this configuration, first of all, I need a private subnet under egress VPC. So I have created two private subnet for the high availability in availability zone A and B. And I have created two public subnet in the same manner, A and B. I will attach my transit gateway with the private subnet in egress VPC, and it is highly recommended to attach your transit gateway with the private subnet. Under public subnet, I deploy a NAT gateway. If you are doing this implementation in your production environment, so I'll recommend to deploy NAT gateway in both location availability zone A and B. But for demonstration purpose, you can deploy one. And then I have deployed a internet gateway so that when requests come to my NAT gateway, it send request to the internet by using IGW. To understand the communication, first you have to understand the routing. So I'll first create the route table under the transit gateway. The first route table is spoke route table. Under this spoke route table, I will associate VPC A, B, and the remote VPC, and will create a route 000/0, which will point to the egress attachment, which is our this VPC. And in other route table under same transit gateway, which is security route table, I will associate egress VPC and create route for VPC A, B, and remote VPC. In other side, on the VPC A, I will create a route. The first is local, so that if virtual machine 1 wants to communicate with the 2, they will follow the local route and communicate. The rest of the communication will follow the other second route, which is 000 pointing to the hub transit gateway. And same thing happen with the VPC B and the remote VPC. In egress VPC, I will create a route for private subnet. The first is the local and second route will point to the NAT, okay, which is 000/0 pointing to the NAT. In public subnet, I will create other route. The first is the local, the second is 000/0, which is pointing to the internet gateway. So if there is nothing matched to this route table, what happen? All the requests will straightforward sent to the internet gateway for the communication. And how the communication will happen? Let's see. Your virtual machine 1 wants to communicate to the google.com or want to access the internet. What happens? It will come to its route table and it will go to the 000 because google.com will not match to this local route. And it come to the hub transit gateway. The moment you reach to the hub transit gateway will see from where are you coming. So you say I'm coming from VPC A. Is VPC A is attached to any of route table? It first look into the route table. It say, okay, the VPC A is attached to a spoke route table. And what is routing of a spoke route table? It say there is one route which is 000/0 pointing to the egress attachment, which is a VPC egress. What happen? Transit gateway will send your request to the egress VPC under private subnet. The moment you reach to the private subnet, it verify where do you want to send the traffic. You say the requester is VPC A wants to communicate to the google.com. What happened? It will send a request to the NAT gateway. NAT gateway, which is under your public subnet. The moment you reach to the NAT gateway will follow its own route, which is this route table. It first see who is the requester. It's coming from VPC A, and where it wants to go. It wants to access the google.com. So it will see whether the route is added here or not. If route is not added, what happen? It follow this route and send the request to the IGW, Internet Gateway. Okay, and the request will be sent to the Internet Gateway, and you will be able to access google.com. Let's talk about other use case. This virtual machine wants to communicate to the VM which is sitting under VPC-B. How they will communicate? It will follow the same route table, come to its own route table and see and send the traffic to the hub transit gateway because the destination is 10.1.0016, which is not matching the local route. It's sent to the hub transit gateway. You reach to the hub transit gateway. Hub transit gateway will verify where is the association, come to this, follow its local route, send the traffic to its egress private subnet. Under egress private subnet, it will send your request to the NAT. Under this, NAT will see who is the requester. Requester is VPC A, and where it wants to go under VPC B, which is 10.10016. It will follow its local route table and see, oh, I have a route 10.1.0.0/16, which is pointing to the hub transit gateway. It will come to the hub transit gateway. Hub transit gateway will see who is the requester. Requester is egress VPC. It see where egress VPC is associated. So it is associated under the security route table. It move your request to the security route table, and then it will say what is the route here, where you want to go. So destination is this. So it will see, okay, destination 10.1.0016 is associated with VPC B. What happened? It sent the request to the VPC B and established the communication from VPC A and B. This is how the communication will happen. To do this implementation, you should be aware how to create the VPC, subnet, NAT gateway, internet gateway. If you're not aware of it, you can go and watch my video how to create the VPC, NAT gateway and internet gateway. I'm using two different accounts. First is the CloudX India, where I have created three VPC, VPC A, B, and egress VPC, and other account is KK1657, where I have created a remote VPC. Let's verify the subnet. So here is the subnet what I have created for all the VPC. And now I'm going to create the transit gateway. How can you access the transit gateway? You can access from the same console. Here is the transit gateway. Click here. It will open this wizard. Then what you have to do? Create transit gateway. Name it hub TGW and click on create. It will take some time, so I'm freezing the video. It's available now. Let's create the route first. So the first route is the spoke route. I'll go under transit gateway, route table. and name it spoke RT. In the configuration, you can see it is saying default association route table is yes and the propagation is also yes. What does it mean? When you attach the VPC with the transit gateway, it automatically create a route table for your VPC. It automatically associate and create the propagation and route table for your VPC. So I do not want the default association and propagation. So let's disable this. Go into the transit gateway, click on action, modify, and remove this part. You can see it's changed now from yes to no, and create the other route, which is our security route, and attach to the same transit gateway. It will take some time. So till the time it is creating, I'll do the association of VPC. So I'll associate VPC A and B, which is under same account. So this is my transit gateway, and it is VPC attachment, VPC A, and attachment. You can select your VPC. You can see I did not do anything special while attaching our local or attaching the VPC which is under same account where is my transit gateway. But when you do the attachment of a VPC which is in different account or remote account, you have to use the RAM. I will share what is the RAM. How can you do that? VPC B attachment. I'll select the VPC B and the subnet, private subnet, create, and create the attachment of egress VPC as well. So it's egress attachment, select egress VPC, and make sure it does not have the public subnet. So it is public, you can make it private and create it. So I have created attachment of all three VPC, which is under same account. Where is my transit gateway? It is taking some time. Till the time it is attaching, let's create the attachment of the remote VPC with the transit gateway. This is my different account. You can see KK1657, and this one is the CloudX India where I have created transit gateway. So to do this attachment, go into the transit gateway. I have opened in different tab. You can see there is no transit gateway and you cannot see it here. Reason why? Because the transit gateway you have created under the CloudX India, which is separate account. How can you share your transit gateway from one account to other so that you can do the association of remote VPC? To do this, you have to use a service of AWS, which is RAM, Resource Access Manager. Open in different console. So under RAM, you can see there are two options: shared by me and shared with me. So whatever the resource you have shared, it comes under shared by me. If there is anything shared with you, it comes under share shared with me. So let's share your transit gateway with other account. Click on create resource share, assign a name, hub TGW, select your device. Click here, select your resource. It is a transit gateway. Click here and transit gateway will appear here. Select it. Then go on remote site, copy the account number where you want to share. You have to copy the account number of that account and paste it here and click on create resource share. It's active. You can see one is deleted, which I have used previous, and the other one is active. Go back to your remote account, open RAM under this account as well. You can see there is an invitation. It is saying one invitation, which is shared with me. Click here, and this is the invitation coming from parent account 1984. You can verify the CloudX India account. It's 1984 ending with. Click here and accept it. The moment you accept it, it will appear under your transit gateway. Just refresh. Okay, and you can see the owner is this. Now go into the attachment, create attachment, name it, select your transit gateway, name it remote VPC attachment, select your VPC. You can see single VPC is here. Select your subnet and create it. So it is pending acceptance. So if you go back to your parent account, transit gateway, you will refresh it, you will see new attachment, which is pending for acceptance. So what you have to do is select it, go in action and accept it. It is now pending. It will take some time to complete. Give a name, remote VPC, so that you can identify it easily. Till the time it is in pending state, let's modify the route of transit gateway. So as per the design, your VPC A, B and remote VPC will be part of a spoke route. So let's associate it. Go into the spoke, click on association, create association, select your VPC A, VPC B, and remote VPC. Okay, it's associating. Now let's create a route, create a static route, CIDR 000/0 and point to the egress attachment. This is how the spoke route is. Now go to the security route, go into the association, associate your egress VPC here, go into the route, create a route. The first is 10.00/16 and point to the VPC A attachment. The other route pointing to B, 172.16.16 point to remote VPC. Refresh it. So all the routes are present here and you can verify your design. We have done this part. Now go to the egress private subnet under your CloudX India. So this is our VPC route. Egress private Go under the private route, create a route and 000 point to the NAT gateway. I have already created the NAT gateway, and then what you have to do, you have to create a route for public subnet. So here is your egress public subnet. Click on edit. The one route is pointing to internet gateway. You can see this one, and I already have created internet gateway. Create the route which will point to the hub transit gateway. I can create multiple at a time. So transit gateway. Click on save. So now a route is ready from transit gateway, egress private, egress public. But on the VPC A remote and VPC B, I have not done the route. I'll create it later. Let's do some test first. So to do this demonstration, I have created 4 virtual machine: VPC A VM, VPC B VM, remote VPC VM, and a bastion host which has the public IP address under egress VPC, so that I can connect this virtual machine and then do the test like ping and the internet access from all these virtual machines. So let's take the remote. So this is the bastion host which is egress VPC. From this virtual machine, I will try to access VM which is under VPC A. So let me take the remote. You can see it is taking time and it will not be accessible. The reason why? Because on other side, on the VPC side, VPC AB or remote VPC, we have not done the routing configuration. So we have to create the route first, then we will be able to access it. You can see it's a fail. So let's do the configuration of routing on VPC A, B, and the remote side. So go under VPC A private route, click here. The first is local. What do you have to do? Point to the transit gateway. And now try to access. You can see it's accessible. But before doing further test, let's modify the route of VPC-B as well. And on the remote side, click on route, transit gateway, and save it. Now let's access it, which is our VPC-A virtual machine. I'll copy the password. You can see I'm able to access it. So from VPC A virtual machine, I will try to access or ping virtual machine which is under VPC B. Let's ping it and see the result. Yeah, I'm able to ping it. It means it's accessible. And try to connect a remote VPC virtual machine as well. So I use the test net connections to check the ports through 389 computer and the IP address of remote VPC virtual machine. You can see it is saying true. It means I'm able to connect this as well. So from connectivity point of view, the first testing is completed, connecting virtual machine from here to there. It's done. Now it's time to access google.com from the VPC-A virtual machine, which I have connected this one. Go into the Internet Explorer. Type google.com. Here you go. So you are able to access the internet. However, there is no NAT gateway or IGW under this account. And same thing you can do with VPC-B and the remote VPC as well. In this diagram, we are sending a request over the internet from A, B or remote VPC. But where are we monitoring our outgoing traffic, outbound traffic? Where are we monitoring what kinds of requests my virtual machine sending over internet or what kinds of page it's trying to access from the internet? There is no monitoring in place at this time. However, we have created a single gate to send all outbound traffic, but there is no monitoring at this time. To implement the monitoring, what you have to do is you have to create the Palo Alto devices under your egress VPC private subnet. You can deploy your Palo Alto devices and do some routing configuration so that whenever there is a request coming to access the internet from Transit Gateway, it land to your egress private subnet and come to the Palo Alto devices. What kinds of site you are going to access? Is this good site, malicious site, or not? Based on the request or the policy, it will send your traffic over the internet. Else, it will block. So to do the monitoring in granular level, you have to deploy your Palo devices or any firewall devices which help you to monitor the traffic. So guys, that's all for today. Hope you enjoyed this video. Please share, subscribe my channel. Thanks again.